Hello students, hope you are doing well. Welcome to my channel where we nurture and learn mathematics beyond boundaries. In today's video, we are going to cover the PYQs for integrals as part of class 12 Applied Math CBSE curriculum. Now before we go to the PYQs, let's first understand the weightage of the chapter. Calculus as a whole has a weightage of 15 marks for applied maths, wherein you have differentiation and integration both. So differentiation carries around 7 to 8 marks, and equally for integration we have 7 to 8 marks. So you cannot skip this chapter or take it lightly. You need to do integration because it has a weightage of 7 to 8 marks, and if you want to score well, you cannot skip it, right? Now before we get into the PYQs, let's first understand the basics of integration. If you are not clear with the basic concepts of integration, go back, pause this video, go back to my channel, watch the videos on indefinite integrals and definite integrals, and then only come to the PYQs. So let's first understand the basics. So we have three things: indefinite integrals, definite integrals, and then applications of integrals. For indefinite integrals, we cover the basic properties of integration, and then we have some properties of integration. Some properties of logs are also used. Then we have integration of rational polynomials. You need to look at the pattern of the question and then see how to solve it. There are some standard integral formulas. You need to learn these formulas, and you might need to apply them directly for your MCQs. Then we have integration by substitution, integration by partial fractions, and last but not the least is integration by parts, right? So if you want a copy of this formula sheet, you can visit my website www.boundlessmaths.com and get your copy of formula card for class 12 applied maths. So let's get started with the PYQs. So the first question is x into e raised to power x upon x plus 1 whole square, and the limits are 0 to 1. So this is a definite integral question. So whenever you have a question on integration, try to understand the pattern of the question. Look at the question and see how to solve it, where it fits in, what category of the questions it is. So whenever you see e raised to power x, think of this property where you have e raised to power x and fx and derivative of the function within the brackets. So now, but you don't see the derivative and the function clearly here. So let's simplify it a little bit so that we can see that e raised to power x dx, put it aside, and then you have x upon x plus 1. Now what do you do in such questions? Balancing, wonderful, plus 1 minus 1. So now you separate both the things, it becomes x plus 1 upon x plus 1 whole square minus 1 upon x plus 1 whole square, and then you have e raised to power x dx outside, and you integrate from 0 to 1. Now this x plus 1 gets cancelled with one of the denominators, so your question becomes integral of 1 upon x plus 1 minus, put a plus here, bring the minus here so that you can clearly see the function and its derivative within the brackets, and then you have e raised to power x dx. So this is fx and this is the derivative of fx, right? Yes. So integral of such a question, you have e raised to power x fx plus c. This is your answer. So in this question it is going to be e raised to power x, and the function was 1 upon x plus 1. So upon x plus 1. In place of c we have the upper and lower limits. So we'll put these limits: e raised to power 1 upon 1 plus 1, which is 2, minus e raised to power 0 upon 1. So the answer is e by 2 minus 1, and this is your final answer. Understood? Easy? Wonderful. Let's come to the second question. Now this is a rational polynomial where the degree of numerator is same as the degree of denominator. When you have a question like this with a rational polynomial with the same degree, what do you do? Long division. So you divide the numerator by the denominator, that is x square minus 3x plus 2. So you will have 2 here, 2x square, and then you have minus 6x. 2 into 2 plus 4, change the sign, this gets cancelled, so you have 6x and this is minus 3. So the quotient is 2 and the remainder is 6x minus 3. So this becomes, the question becomes 2 plus 6x minus 3 upon x square minus 3x plus 2. Put the entire thing in brackets and then a dx. Now you have, let's simplify it a little further. So it is integral of 2 plus, take this 3 out, 2x minus 1, factorize the denominator, it becomes x minus 2 and x minus 1, and then put this entire thing in brackets and then dx. Now how do we integrate such an expression? Think about it. Yes, you can do it. Yes. Yes, by partial fractions. So now that means you put 2x minus 1 upon x minus 2 into x minus 1 as a upon x minus 2 plus b upon x minus 1. Take the LCM and equate the coefficients of x and the constant term. So what do you get for a and b? Let's see. So it is 2 equals a plus b, coefficients of x here, and on the left side that means a can be written as b minus 2. Next you have minus 1 equals minus a minus 2b. So if you put a as b minus 2, this is the expression, and if you solve it we get minus b plus 2. It should be 2 minus b here, not b minus 2. So a is 2 minus b, put it as 2 minus b here. So minus 2 plus b minus 2b, and that makes it minus b, bring it to the left side, b will be minus 2 plus 1, so value of b is minus 1. If you put this value in this expression, we get the value of a as 2 minus minus 1, so the value of a is 3. So we have the value of a and b, that means now we can use the partial fractions to integrate the function. So the integrand is 2 plus, let's keep 3 outside for now and write the partial fractions. A is 3. So it is 3 upon x minus 2 plus minus 1 upon x minus 1, and put this entire expression into bracket and dx, right? Now it's easy to integrate. Wonderful. So let's integrate this. This becomes 2x plus 3 into 3 becomes 9. 9 log of x minus 2 minus 3 into 1 becomes minus 3 log of x minus 1 plus the constant of integration. Don't forget the constant of integration for indefinite integrals. Use the property of log and bring this constant as exponent. This becomes log of x minus 1 to the power 3 plus the constant. Then you have 2x plus club both the log terms. So it becomes log of x minus 2 to the power 9 upon x minus 1 to the power 3 plus c. So this is the final answer. Understood? So whenever you have an expression with 2 or more log terms, club them and get one term for log, right? Okay, so let's move to the next question. Now this is a question on definite integrals involving a modulus function. So in such cases you need to break the modulus function in a way. Look for the value of x where this expression becomes 0, so it is 2. So that means you break the limits as 0 to 2 and then 2 to 4. How do we write the function from 0 to 2? It is going to have a negative value for the function because it is a modulus function, and from 2 to 4 it is going to be whatever the function is as it is, right? Now this question is very easy to integrate. Minus x square by 2 minus 2x plus 2x, okay, and then limited by 0 to 2 plus integral of x minus 2 is x square by 2 minus 2x, and this is also limited by 2 to 4. If you put the value of 2x as 2, it becomes minus 4 by 2 plus 2 2s are 4 minus 0. Okay, and this is 4 square is 16, 16 by 2 minus 4 to the 8 minus 2 square is 4 by 2, minus into minus becomes plus, and 2 into 2 4. So this becomes minus 2 plus 4 plus 8 minus 8 minus 2 plus 4. 8 and minus 8 gets cancelled, minus 2 and 4 gets cancelled, so we are left out with only 4. Now this question uses properties of definite integrals, even though this is not part of the syllabus for session 20, 25, 26, but it was just a very small question on a modulus function, so that's why I took it. So let's move to the next question. Now this question is very important because when you look at this question, you don't understand where it fits in. No formula, no rational expression. What do I do with this question? So you need to use integration by parts here, ILATE. So for you, it is logarithmic functions, algebraic functions, and then the exponential functions. So here you see only log, there is no other function. So assume there is a 1 here, so this log becomes first function and 1 becomes the second function. So you need to use integration by parts here. How do we do that? First function into integral of second function. Don't forget the limits. Minus integral of derivative of first function into integral of second function. Put these brackets and a dx, don't forget this, you will lose half mark here. Now you integrate it, log of 1 plus 2x remains as it is, into x, and the limit is 0 to 1, integral from 0 to 1, derivative of this is 1 plus 2x into 2, chain rule, you need to apply chain rule here, right, into integral of 1 is x, put the brackets and put a dx. Okay, now let's put x as 1, so this becomes log of 3 into 1, which is log 3 minus 0 minus integral of 0 to 1, you have 2x upon 2x plus 1 dx. Now again, how do we integrate this part? Look at it carefully. You can do balancing for sure. Yes, balancing, wonderful. So outside you have log 3, let it be, minus, break it up into two parts. So it becomes 2x plus 1 upon 2x plus 1 minus 1 upon 2x plus 1, and then you have this dx. 2x plus 1 gets cancelled, so that means this becomes, outside you have log 3 minus integral from 0 to 1, you have 1, and then minus 1 upon 2x plus 1, and this is dx. So this is what you need to integrate now. So this is easy to integrate, log 3 remains as it is, minus integral of 1 is x, and this is minus log of 2x plus 1 upon 2. Why do we have 2 here? Integral of 1 by x is log x, but when we have a linear function in place of x, then we need to divide log of 2x plus 1 by coefficient of x, which is 2 here in this case. And this needs to be limited by what? 0 and 1. So now let's put x as 1. So we have 1 minus log of 2 plus 1 is log 3. So it is log 3 upon 2 minus 0 and minus into minus plus log of 1 by 2. Right? So this is log 3 minus 1 minus into minus plus log 3 by 2. This is 0 and log 1 is also 0, so this term also goes away. This is what you have. Club both the like terms, log terms. It is 1 plus half becomes 3 by 2. So it is 3 by 2 log of 3 minus 1. So this is your final answer. Understood? Wonderful. Let's come to the next question. Now this question is an MCQ question and it was there in 2023. So the question is x minus 1 e raised to power minus x. Now here you have e raised to power minus x, not e raised to power x. So let's try if we can put something and simplify our work. So if you put minus x as t, minus dx will be equal to dt. So the question becomes integral of x minus 1. What is x from here? X is minus t. So this becomes minus t minus 1 and then e raised to power minus x. E raised to power minus x dx. So it becomes e raised to power t and dx is minus dt. So dt here and a minus here. Now merge these minus signs, so it becomes integral of t plus 1 e raised to power t and dt. Now this is again a special form of the integration where we have e raised to power x outside and x plus 1 function and its derivative in the brackets. So that means the answer is e raised to power t into t plus c. Replace t with the original expression, so it is minus x e raised to power minus x plus c. So the third option, option C is the correct answer. Again an MCQ, won't be very tough, just think how to integrate and it will be easy to do. Let's move to the next question, again an MCQ question, it was there again in 2023. Let's try to simplify it before we think of how to integrate, right? So this is the question given to you. And you understand that the integral of, what is the integral of 1 plus log x? Integral of 1 plus, derivative of log x. What is the derivative of log x? You can see the derivative is already there, x. So that means if you put 1 plus log x as t, the work gets easier, 1 by x dx becomes dt. And let's see, we have 1 by x dx, so the question becomes dt upon t. The integral is log of t plus c. This means log of 1 plus log x plus c. So if you look at option D is the correct answer. Easy? MCQs are easy. Don't complicate them. Next question, integral of e raised to power minus x upon 1 plus e raised to power x dx. Now here again it is e raised to power minus x, not e raised to power x. So let's first make it positive and then try to understand how can we do this. Now if you look at this, it is not fitting into any of the patterns, and we can try to substitute e raised to power x as t. So e raised to power x dx will be dt, and dx will be, if you bring e raised to power x to the other side, which can be written as t, so it is 1 by t into dt. So now the question is 0 to 1 integral of 1 upon t into 1 plus t, and dx to be replaced by 1 by t into dt. Now because we have another t here coming in, so it becomes t square and this is dt. What should be used here? Think about it. What should be used here? Integration by partial fractions again. So that means you need to put 1 upon 1 plus t into t square as a upon 1 plus t plus b upon t plus c upon t square, right? Now let's equate the numerator. A into t square plus b into 1 plus t into t plus c into 1 plus t, right? So just simplify it once. A t square plus b t plus b t square plus c t. Equate the coefficient of t square, which is 0. So 0 is equal to a plus b. That means a is equal to minus b. Then we have coefficient of x, coefficient of t basically, not x. So that is also b plus c is 0. That means b is also equal to minus c. Now equate the constant terms. It is 1 equals, what is the constant term here? Only c. So that means the value of c is 1. Put it here. That means value of b is minus 1. And if you put it here, the value of a is 1. So you get a as 1, b is minus 1 and c is 1. So we have the partial fractions ready for the question we have. So that means the okay, when we are using, when we are substituting, here we need to take care of another thing is when we are replacing or when we are using substitution with definite integrals, we need to change the limits also. When the variable was x, the limits were 0 to 1. So if it was variable was x was tending to 1, then that means t is tending to e. And when x is reaching 0, the lower limit is 0, that means e raised to power 0 is 1, so t becomes 1. So now my limits are 1 to e. So you need to take care that you have to change the limits also when you are changing the variable. So now we have the partial fractions ready. Let's solve it further. Integral from 1 to e. So this expression can be written as a is 1. So 1 upon 1 plus t. B is minus 1. So it is minus 1 upon t, and then c is also 1 upon t square, and you integrate this. Right? So this is easier. This becomes log of 1 plus t minus integral of 1 by t is log of t. And then what is the integral of plus 1 by t square? It is t to the power minus 2. So this becomes minus 1 by t, and the limits are 1 to e. So put t as e. So it becomes log of 1 plus e minus log e minus 1 by e, and then you put it as 1. 1 plus 1 becomes 2. So it is minus log 2. This is minus log 1, and this is minus 1. Right? So the expression now is, merge the log terms, it becomes 1 plus e upon e minus 1 by e, and what is in the bracket? Log 1 is 0, so it goes away. And you have minus log 2. So there is minus into minus plus 1 also, right? So this is your final answer. It cannot be simplified further. So this becomes your final answer, log of 1 plus e upon e minus 1 by e minus log 2 plus 1, right? So if you do it carefully, make the partial fractions and then integrate. Next question, again an MCQ, and this is very easy. If you look at the question, the base are constants, so easier to evaluate. 2 to the power 2x can be written as 2 square is 4, 4 to the power x into 3 raised to power x dx. So that becomes 4 into 3, 12, integral of 12 to the power x dx. That becomes a to the power x. What is integral of a to the power x? A to the power x upon log a and then plus c, constant of integration. So that means option A is the correct answer. This question was there in 2024. So there are questions for integration that come in the board exam. There have been few questions from integration part, indefinite and definite integrals. Please do these questions carefully, and once you are thorough with this, only then you can attempt questions on applications of integrals, right? So if you like the video, share the video with your friends. Share the formula sheet from Boundless Maths with your friends and keep watching. Till then, subscribe to the channel so that you keep getting notifications. Don't forget to press the bell icon to get notifications on uploaded videos that are being there added to the channel. And keep learning, keep growing. Thank you.